Hello, welcome to this session on probability. My name is Theod Nirinda and I'm a teacher of mathematics at Gayaza High School. Probability is a measure of the likelihood of an event happening from many outcomes. Probability arose out of the games of chances, and in everyday setup, we experience probability. Take an example of a weatherman forecasting how many days in a week are going to be sunny. We know that a week has 7 days, and the 7 days form what we call the possible sample space. The 7 days could be represented by S, and we can have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Now, these 7 days form what we call a sample space, and we can easily determine the number of the possible space. And in this case, our number would be 7. So 7 is the total number of days, and if, for example, the foreman projected that in the 7 days we are going to have 3 days that are going to be sunny. And for example, if I took the 3 days are going to form what we call the event, and if I represent my event with letter E, and for example, I take Monday, maybe I take Wednesday, maybe, and Friday. So if he projected that Monday, Wednesday, and Friday are going to be sunny, it implies that the 3 days are going to form what we call the event. And in our number of events, we can have the 3 days, and we can determine how many they are by saying the number of possible events is 3. So to get the probability of the event that it will be sunny in a week, we shall use the classical definition of probability, which is the number of elements in the event set over the number of elements in the sample space. And this gives us 3 out of 7. We can also look at another scenario of a pregnant mother. We expect either a boy or a girl, meaning that our sample space will have 2 elements, which is a boy and a girl. And if we are required to determine the probability of getting a boy, then our event set will have a boy, meaning that to get the probability of having a boy, we shall have 1 out of 2. Let us now look at the following example. Take a scenario where you are having 2 fair coins and the coins are tossed at once. So the example we are going to look at is 2 fair coins are tossed at once, and in part A they want us to show the possible outcomes on the possibility space. In part B they want us to find the probability of getting the same side. Now, in this setup, if we can depict our probability, We know that a coin has two sides, and we can call these sides a head and a tail. So, if I represent the first coin this way, I can have the first coin having two sides, and the possible setup is a head and a tail. The same applies to the second coin. Can have a head and a tail there. So when these two coins are tossed, there is a possibility of having a head and a head. A head on the first coin and a head on the second coin. And it is that setup. Or we can have a tail on the first and then a head on the second. Or we can have a head on the first and then a tail on the second. Or we can have a tail on the first and a tail on the second. So, what we are seeing here, we call it the possibility sample space. And in this case, we have 1, 2, 3, 4. So our possibility sample space, which I represent with S, I can say it is head, head, or I can say tail, head, or I can say head, tail, or I can say tail, tail. So you realize that these are four possible outcomes, and if I'm to determine the number of the possible outcomes, I will say it is equal to 4. However, in part B, they are saying you determine the probability of getting same side. Now, let's go back to our possible sample space. What are the possibilities of us getting the same side? Same side means you can get a head on the first coin, and then you can get a head on the second coin. And that scenario is that one. Or we can have a tail on the first coin and a tail on the second coin. And in that case, we have that. So, to determine the probability, I can say that the number of events, it is head, head, and then tail, tail. So, number of events, we have 2. So, to get the probability of getting same side, we can say it is the probability number of events out of the total. In this case, we have 2 out of 4, and we always simplify our probabilities because probability is a fraction. So we can simplify it. When you cancel by 2, you get 1. By 2, you get 2. So our final answer becomes 1 out of 2. And that answers part B. We can as well look at other scenarios. For example, if I take another example of an ordinary die. We know that an ordinary die has 6 sides, and the 6 sides can be represented by 1, 2, 3, 4, 5, and 6. So, an ordinary die, if it is thrown, they can ask you to find the probability of the number that will show up. For example, in this question, an ordinary die is thrown. Find the probability that the number obtained is a multiple of 3 for part A, is a factor of 6 for part B. So what we are going to do, we are going to determine how many multiples of 3 we are having out of the possible sample space. And in that case, for part A, I'm going to let A be the event. So if we let A represent a multiple of 3, we go back to our sample space and we determine how many numbers are multiples of 3. So when you go back to our sample space, 3 is a multiple of 3 because if you get 3 times 1, you get 3. Then the other one is 6. If you get 3 times 2, you get 6. So we have, for our event, we shall have 3 and 6. And this implies that the number in our event is going to be 2, because there are 2 members within that set. Now, the question is asking us to determine the probability of getting a multiple of 6. I mean a multiple of 3. So we are going to say that the probability of A, remember I've defined A as an event of getting a multiple of 3. So probability of A would be the number of events out of the sample space. Remember our sample space here is 1, 2, 3, 4, 5, 6. So there are 6 numbers in total. So you come and substitute your values here. You say 2 out of 6. Remember, this is not simplified, so you go ahead and simplify it. So it implies that your final answer is going to be a third. It is important that when we are doing probability, we always simplify our answers to the simplest format that is there in the question. So this answers part A of the question. And if you look at part B, in part B, they are saying we find the probability of getting a number that is a factor of 6. Now, I'm going to let B represent that event. So I can say, let B be the event. Factor of 6. It is always good to use a letter to represent events because it saves you the space when you are working out your probabilities. Now, let's go back to our sample space. How many factors of 6 do we have in our sample space? The first factor is 1, because when you get 6 divided by, when you get 1 times 6, you'll get 6. Then the other one is 2, because if you get 2 times 3, you'll get 6. Then the other one is 3, because if you get 3 times 2, it gives you 6. And then finally, you have 6, because 6 times 1 gives you 6. So what you are seeing here circled form the number of events that a factor of 6. And if we represent these members, we can say 1, 2, 3, 6 are the members. And how many are they in total? They are 4. So, to get the probability of getting a number that is a factor of 6, I'll come here and say probability of B. Remember, B is representing the factor of 6. It's going to be the number of events, and in this case, we have 4 over the total sample space. Now, when we substitute for the number of events, we are going to get 4 divided by 6. You realize that this is not a simplified fraction, so we go ahead to simplify it by 2, 2 by 2, 3. So the final answer we get in this case is 2 out of 3. And that answers our question for probability. Let's look at another scenario when 2 dice are tossed. Here is the question. 2 normal dice are thrown at the same time. Find the probability of getting part A, at least 1, 4, part B, a total score which is a prime, part C, probability of getting a total score of 3, that's part 1 of C, 5, that's part 2, 7, that's part 3, and finally 11, that's part 4. Now, to attempt this question, we shall consider the number that appear on the top face when a die lands, and the question requires us to sum up the numbers on the 2 dice in order to determine the score. The possible outcome is explained in the video below. Consider 2 unbiased dice, that is, both have faces marked from 1 to 6. Toss the 2 dice at a go and note the number on the side that appears on top for each die. The table shows the possible outcomes in blue color. When the numbers are added, we get the sum of the scores or total score in red color. We can use the total scores to attempt the questions that follow. The probability of finding at least 1 4 requires us to find all possibilities with 1 4 or 2 4s. For example, you can have 4 1, 4 2, 6 4, 4, 4, to name but a few. Hence, finding the probability of at least 1 4 is equal to 11 out of 36, since there are 11 in total. The probability of determining a total score which is prime requires to determine all sums that are prime numbers. For example, 2, 3, 5, to name but a few. Hence, the probability will be 15 out of 36, since there are 15 prime numbers in total. The probability of getting a total score of 3 is equal to 2 out of 36. Since we have 2 sums of 3's, this reduces to 1 out of 18. The probability of getting a total score of 5 is equal to 4 out of 36, since we have 4 sums of 5, and this reduces to 1 out of 9. The probability of getting a total score of sum of 7 is equal to 6 out of 36, since we have 6 sums of 7's, and this reduces to 1 out of 6. The probability of getting a total score of 11 is equal to 2 out of 36, since we have 2 sums of 11, and this reduces to 1 out of 18. I hope the scenario tries to put into perspective what happens when 2 dice are thrown, and I hope it has enlightened you on what probabilities can be asked when they want you to determine the sums. Let's look at another scenario where we toss a coin and a die. The example is a fair coin and die are tossed at once. Part A, construct a table showing all the possible outcomes. Part B, what is the probability of getting a tail and a prime number? So let us see how our possible outcome is going to look like. Sorry? Okay, so our setup looks like this, and a die has 1, 2, 3, 4, 5, 6, and a coin has 2 sides, which is a head and a tail. So when the 2 are tossed at once, what is the possible outcome? We can have a 1 appearing on the die and a head. You can have a 2 and a head. You can have a 3 and a head. You can have a 4 and a head. 5 and a head. 6 and a head. or we can have a 1 and a tail, a 2 and a tail, 3 and a tail, 4 and a tail, 5 and a tail, 6 and a tail. So this forms our possible sample space, and we can determine the total number of events in our possible sample space, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'll come here and say the number in our sample space is 12. Now, in part B, they are asking us to determine the probability of getting a tail and a prime number. Now, when you go back to your sample space, you can focus more on that part which has the tail, and then you determine which parts are having prime numbers. Now, we know that a prime number is a number that is divisible by 1 and itself. Now, when you look at the outcomes for this part of the tail, we are going to let A be the event of picking a prime number and a tail. Now, the first setup is 2 and a tail. The other one is 3 and a tail, and then 5 and a tail. So it implies that if you let A be if you let A represent the event of getting a tail and a prime number, then we can have in our the number of elements in A as 2t, 3t, and 5t. And in total, there are 1, 2, 3. So I'll come here and say the number of events in A are 3. Now, how do we get the probability once we've identified how many members belong to our setup? Yes? Now, the probability in this case is going to be the number of events out of, and we know that our number of events is 3, and our total is 12, meaning if we reduce it, we will come up with 1 out of 4, and that becomes our answer for part B.